So, so we have discussed the protocol, the application protocol for users, including DNS, mail protocols, SMTP, POP3, and IMAP4, and World Wide Web protocol, which is HTTP. And we also look at the FTP protocol, which has out-of-band signaling with two connections, one for control and one for data. Now let's move on to the next one, which is SNMP. However, it is not for ordinary users, but more for administrators, network administrators, where the other network administrator can issue the SNMP messages to get some management information from the devices being managed. So the device being managed would have some SNMP agent running on top of it in order to be managed. So that's the management protocol. And we'll look at the how the structure is, how the architecture looks like, and then we look at the management information base, which is to be supported by the SNMP agent on the devices being managed, and then the SMI, structure management information, which is a language to describe MIB, the MIB. And then the protocol, SNMP, Simple Network Management Protocol, which is the protocol between the manager and the managed devices. So in a sense, it's between the client and the server. But now the client is the manager, but the server is the device being managed. Okay, so if I have many switch and routers, these are devices to be managed. Then they would serve as SNMP servers, while the manager, for example, I'm running a management program, and this management program will run as an SNMP client, while those switch and routers would run as a SNMP server. Okay, then we have an open source implementation, which is Net SNMP. So we need to have a way to manage the network systems, and there are some tools that you can use, like ping, traceroute, netstate. Most of these are based on ICMP messages, control messages. Okay, however, it's not enough. It would just give you some limited information you need. You might need more information from the devices being managed. So in a sense, the SNMP protocol is to do remote control and management without being physically attached to the managed devices. And it is used to exchange management information between the network devices. Okay, so right now it has 3 versions developed, with the newer version adding on some new features. For example, the version 2 has functionality enhancement. Version 3 has some security adds-on, so that it won't be used, the SNMP message won't be used by non-administrators. It will be only used by administrators. Okay, so here's the framework or the architecture, where you have the manager, usually a computer running a management program, it would then use SNMP protocol messages to a device being managed. Suppose this is a router or a switch. Okay, and these devices has a MIB, need to maintain a MIB, management information base, which describe the status of this device. And we will see what MIB information we have. But MIB is a management information base, is a database to describe the status of the device being managed. And on this device, there must be a program, a tiny program, which is called SNMP agent. SNMP agent running on this device. So this agent program will then handle the SNMP request from the manager, and the request might be asking to retrieve or configure, retrieve or set the MIB information. So if it's retrieved, then I will send SNMP response back with some particular MIB values in the SNMP message. So the manager issue SNMP request, while the agent respond with some particular MIB value, so that the manager will be able to collect some management information and then do some decision. For example, it might decide to set some of the MIB value here. Okay, so it then issue SNMP query again to set the MIB value from, say, on to off. Then the agent will do the job to do the actual setting. So in a sense, the agent running on the device being managed is like a server, SNMP server, while the manager is more like a client sending SNMP request. However, there are some devices that do not have do not support SNMP. For example, on these three devices, there are three devices, but they don't support SNMP. So what happened is that there needs to be a device here that supports SNMP, that can talk to the manager through SNMP. However, this device also manages the other devices, and with a protocol different from SNMP. So another protocol. So if they don't support SNMP, then you need to do it this way. But in the normal case, it will be this, where the devices support MIB and SNMP. and in the industry, they call a device, say a switch, supporting SNMP and MIB as the intelligent device, intelligent switch, while calling the switch which does not support SNMP and MIB as dumb switch. So when you're saying dumb switch or intelligent switch, you are saying whether they support SNMP and MIB. If they do, they are called intelligent. So these are dumb devices. They don't support SNMP. This is intelligent device. They support SNMP. Okay, and now you need the MIB value to capture the status of the device. So we need to look at how the MIB is represented. And actually, it can be described. It's like a database where the database, in order to describe a database, you need to have a schema, right? In database, you have a schema to describe a database. And that schema here, the language for that schema is called SMI, Structure of Management Information. And the management information base is more like a tree-like structure, and identified by the object identifier. So it's like this. It's the MIP. There's MIP1 and MIP2. And MIP2 is commonly used as a part of the standard information base that should be supported by a managed device. A device being managed. Okay, so you have a MIP3, something like this, and here the MIP2 has 9 categories or 9 groups, into 9 groups from the system. Under this group, there could be a object. There will be object describing the CPU, the memory, the operating system. All those are related to the system. And then an interface describing whether this is Ethernet card or wireless LAN card, and the MAC address. So these are the interface. Same for this, that will be the interface too. And then IP, you would have IP address and the traffic volume of IP packets. And then ICMP, traffic volume, mostly traffic volume, accumulated number of packets of ICMP packet. And then TCP, how many TCP connections has been established, how many segments have been sent on these connections. Same for UDP and the others. So under each group, there could be many objects. Those are defined objects. So for example, so if you want to identify this object, and under this object, there could be many objects. Okay, to identify this object, you would have an identifier of this 1.3, 1.3.6.1.2, 0.1.4. That'll be this 1.3.6.1.2, 0.1.4. Okay, so with this kind of representation, object identifier, then you can traverse a MIP tree and then pinpoint which object you want to retrieve or set. Okay, so that's the MIP2. And here there is a description about those 11 groups. Is it 11 or 9? 1, 2, 10. 10 groups. 10 groups under MIP2. Okay, and to describe the object, you need a language, and that language is ANS.1, abstract syntax notation 1, which is a language to represent objects. So it'll be something like this. So here it's a schema, the MIP schema. Which MIP? The TCP connection table. The TCP connection table is a part of the MIP. It's one object of the MIP. And you could use ASN.1 syntax to describe its schema, and it's described in this way, where you have TCP connection table here, and it says that it's a sequence of TCP connection entry. So it's an array of TCP connection entry. And here's the definition of TCP connection entry. say, so it says it's a TCP connection entry, and with this attribute, and an entry would have this field, TCP connection local address, TCP connection local port, TCP connection remote address, TCP connection remote port. So this is actually what? The socket pair, the so-called socket pair. IP address, source IP address, destination IP address, source port number, destination port number. That's the socket pair. and that's the index. These fields are used as index into the table. There are also other okay. So this is the field you have. In addition to the IP address and port number, there's a connection state, which is an integer connection state. And the connection state could be this. These are the I think the 11 state. 11 state we have seen in TCP state machine in chapter 5. In chapter 5, we have seen the TCP connection state machine, which has 11 states. These are the 11 states here. So the 11 state here. So the connection state could be one of these 11 states. And then you further describe what is the connection, TCP connection local address, TCP connection local port, TCP connection remote address, TCP connection remote port. And then so you describe there what they are. So these are in the syntax of ASN.1, just to describe the object, which is called TCP connection table. And one example of the TCP connection table is like this. This is one object with the object identifier of this. This is identifier. And now you got 4 entries. 4 entries, meaning 4 connections. And these are the connection state of these 4 connections. And then the socket pair here, socket pair. And this 4 entry, this 4 field is used as index into the TCP connection table. Okay, so this is one TCP object. And if you could retrieve each, you could either, if you are a manager, you want to retrieve to check how many what TCP connection has been there on a device being managed, for example, on a router or on a switch. You want to check that. Then you could issue SNMP query and specifying the MIP identifier, the object identifier, and then it will give you normally it will give you the first entry. The first entry will be this. And then the second entry, and the third entry. However, you could get each entry by each SNMP query. But that would take too much time, too many rounds in order to retrieve the entire table. So another way is to have block retrieval. You retrieve the whole table. You could retrieve the whole table by just issuing one SNMP query. So then you would not just retrieve one entry at a time. You could retrieve the entire table in one SNMP query. So the manager will get the entire table and then does the management job. Okay, so here's some protocol data units that you could issue. Say you could get request. the SNMP query, you could get request, retrieve the value of a specific object, and get next request, get the object in the next object in the tree, or set a request. You can set a particular MIP value. Some of the MIP value are read-only. Some of them can be read and written. So some are read-only, some are read and write. For those who can attack write, then you could set the value. You could set the MIP value. So set request is more like a management action. So for example, you want to disable the interface. You could disable the interface. Then you need to use a set request. And then get response. Okay. And then there's a command called trap, SNMP command called trap. It's the trap message is not issued from the manager to the managed object or managed device. It's from the managed device to the managers. So the agent, I mean the managed device could proactively send a trap message to notify the manager. Okay. If some MIP value exceed a threshold, for example, if I'm a manager, I might set the MIP value, set a condition. If the MIP value is over 5, then send me a trap. Send me a trap. So the agent would then send a trap to the manager if that particular MIP value is over 5, for example. And as we said that we could retrieve the MIP objects one by one, one value by one, but we could also get a block of data, a block of MIP values in one shot. For example, multiple rows in a table. You want to retrieve multiple rows in the table, the entire table. Then you can send a request, get bulk request, in order to retrieve the entire table. So that'll be more efficient. Okay, so the table, it was written as this. It was written as this, but actually it's more like this. And so here the identifier of the entire table is this. This is the identifier of the entire table. And you could retrieve any of the objects here with additional objects. I mean, with additional identifier. Say, for example, if this is X, and the first entry will be .1, and the connection states of the first entry will be .1. The TCP connection address, local address, will be X. X is this. X is this. Okay, X.1.2. Okay. Okay, there are some enhancement in SNMP newer versions to deal with mostly to deal with the security issue, so that it makes sure that only the administrator can access SNMP, not the ordinary users. So then access control and encryption and authentication. Okay, so the Net SNMP is a project, open source project, and it has SNMP agent that could be installed on a device being managed. Again, the agent on the device being managed work more like a server, work more like a server, while the manager work more like a client. So it has a SNMP the SNMP daemon, and SNMP trap daemon. They are to be installed on the device being managed. So they are SNMP agent and run more like a server. And this open source project also provide a very simple manager that you could examine. They call it a MIP browser. It provides a MIP browser that you can browse the MIP value. So it provides some commands, say SNMP get, set, bulk get, SNMP walk. You could walk through a MIP tree, SNMP trap. Okay, the agent could proactively send the trap message to the manager, and status, retrieve the status of the agent, or check the statistics. These are the commands provided by the Net SNMP project for the manager. These are provided for the manager. So here's the example, command line example, where you issue this command under the command line, and then it actually send the SNMP query, send an SNMP message to the agent running on a device being managed, and then get back the response, and then display the response on your console. Okay, so the SNMP work on top of UDP. So it's writing a SNMP agent or writing an SNMP server daemon process is simple. That it uses the select system code here. Use the select system code to do I/O multiplexing, and then retrieve the MIP information, and then send back the response back to the manager. Okay, so so the SNMP implementation, agent implementation is more like an iterative. It's an iterative server that does not provide concurrency, because the service time to handle an SNMP message is short, so you don't need to handle the concurrency. You just work iteratively, and you handle the SNMP query, and it's done, and you go back to the select.